C# 8.0 came out recently, so in this video, we're going to go over some of the new features we can use in C#, including read-only struct members, default implementations and interface methods, switch expressions, easier using declarations, better index and range options, and more. The source code for today's video is available to download using the link below in the description. You'll also find links there to sign up for my mailing list and for my Patreon. Mailing list members and Patreon members get special perks, including special offers and discounts. For example, next week, there'll be some special offers for each group because of the special event surrounding the upgrading to .NET Core of the TIMCO Retail Manager. Now sign up for each now so you're sure to get all the offers. Now if you haven't come across me before, my name is Tim Corey and it's my goal to make learning C# easier. One of the ways I do that is by teaching context. There's a lot of tutorials out there that teach you what to do. I go a few steps beyond that to show you when to do it, why you should or should not do it, what the pitfalls are to avoid, and what the best practices are. Basically, I get you ready for the real world. If that's the type of training you are interested in, subscribe to my channel and hit the little bell icon to be notified when I release new videos. Okay, let's go to Visual Studio. And we're going to start a simple console application. And the reason why is because we're just showing off these features in a demo mode. I'm not putting these into a real world style application right now. I just want to show you the basics. Let's call this C# 8 and C# 8 demo. Now hit create. And once that gets created, what we're going to do is wipe out this console write line. We will put a console.read line at the end. Okay, so we've got our console application set up. It's ready to go. Now let's talk through the different pieces we're going to add. What I'm going to do is I'm going to add a class file for each of the different things we're going to look at. That way, when you get this source code, you can pull it out and say, okay, I want to look at just this and see the example right there. I'm also going to put some links if they're helpful to the various parts of these things so you can get more information if you want to. Okay? But let's start with talking about C# 8. What does it mean C# 8? Because we're in .NET Core 3.0. So where does C# 8.0 come in? Well, C# is the language. And so the compiler, as long as it's updated to support it, will compile C# 8 code, regardless of what .NET version you're using. So technically, you can get C# 8.0 code to work in the .NET framework. However, that's kind of a hack. This was designed for .NET Core 3.0 projects. So that's where the C# 8 comes in. So C# 8 is the language. .NET Core 3.0 is the framework or the thing that compiles the C#. Okay, so there are differences, and yes, that's a little confusing. We have different version numbers for different things that seem like they're the same thing. But that's the difference. C# 8 is the language. Okay, so let's look at our first thing we're going to add. So I'm going to add a class. And this naming is not a naming convention I want you to follow. Again, this is just a demo application. I'm going to start with 1-. I normally wouldn't do this. But what this will allow us to do is it will allow us to refer to things by numbers, and it will allow us to order these. Okay, so read-only members. Now notice the 1- read-only members. The class file is _1_, which is not exactly the same thing. That's because this naming is not great, okay? But we're not going to worry about it because we're actually not even going to keep the class. We're going to get rid of it. Because read-only members talks about structs. So let's create a struct. So public struct rectangle. Okay? And I'm going to create two properties. Let's create a double that is the length and a double that is the height. Okay? Now, if you're not familiar with a struct versus a class, because it looks a lot like a class, a struct is a value type where a class is a reference type. And so that determines if it's on the heap or the stack, and it determines how performant it is. And there's a lot of things behind it. I'm not going to teach you all about structs in this video. Typically, though, we don't use structs. We use classes unless the struct is something that's small and we're going to use briefly and then throw it away. A class instance is more often used for lots of data where we're going to maybe keep it a little longer term. Okay, so that's the really high level overview of struct versus class. But a struct, when you copy this, so if you assign this to a variable and then you pass it into a method, since it's a value type, it's going to make a copy of this entire struct and pass it into the method, whereas a class just passes the reference. Okay, so there's some performance benefits to that. There's also some performance drawbacks as well. But one of the things you can do in a struct is you can say, let's do a public double area. So it's a method. And this method is going to return length times height. Now, if you were to create an instance of this rectangle and you were to pass it into a method, and then you call this area method, the compiler behind the scenes, the system processing it, is going to say, I might need to make a defensive copy of this because this method may change something. And it doesn't know. Okay? Now, in this case, it's not changing anything. It's just returning length times height. That's not making a change internally. But what's going to happen is it's going to make a defensive copy. And that copy takes a little bit of extra memory. So what we can do is make it a read-only member. So we can say public read-only. All right? And that allows us to say, hey, you know what? That's not going to make any changes internally. Therefore, you don't have to make a defensive copy of this rectangle. Therefore, you can save that memory. So essentially, it's a performance optimization. If you are saying the area does not make any changes internally, you mark it read-only, and then the system knows performance-wise it doesn't have to make that defensive copy because it's read-only. Therefore, you are a little bit more performant in your application. Now, that's a small subset of the code you're going to write, as far as you're not going to do this very often. But I did want to highlight this for another reason. Okay, so you're not going to use this very often. So don't just start going and creating structures all the time because Tim showed you how to do it once and it looks pretty cool and you can do read-only. Don't do that. Okay, but if you have a struct and you can mark something read-only, do it. And here's why. Not only does it make it more performant, it also makes sure that you protect your intent. So if you expect that this area does not make any changes, later if you come in and say, you know what, I'm going to say height plus equals 1. It says, cannot assign a height because it's read-only. Well, height's not read-only, but this area is marked as read-only, and it's saying, hey, since this is read-only, it cannot change the structure internally, therefore you can't do this. So it protects your intent. And that's of probably even more benefit than even the performance gain you get. Now, what you're not seeing is the fact that it's actually marking these getters as read-only as well, which doesn't really make sense at first, because you're thinking, well, but you can also set, and that's not read-only. That's right. Yes, but the get method is read-only, and that's what's important. Because let's make a change here. Let's change height to be a full property. So I'm going to say prop full on a double, let's say height, like so. Now look at our area method. We've got a green squiggly, and it says call to non-read-only member rectangle.height.get. from a read-only member results in an implicit copy of this. There's that defensive copy. Okay? Because it might actually make a change. We can fix this by saying that this get is read-only. It's a read-only get. Now that's solved. And you may say, well, that's just stupid because this whole thing shouldn't need to say read-only. It should be assumed that the get, which is just getting a value, is read-only. But it's not stupid, and here's why. Because yes, this is the standard get, but what if I said height plus equals 1? I can do that. Should I do that? Probably not, but I could do that. Maybe this is, how many times have you read me? And so it just increments by 1 and then returns it back. Well, that makes a change. Therefore, that's a read-write. So that's where that copy, the implicit copy of this, is going to happen. So if I mark this as read-only, it's going to say that works, but you can't do this because it's read-only. Cool. Okay, I can solve that. Now, the next thing you can say is, you know what, instead of saying read-only here, I'm going to say read-only here. And that works except for one thing. You can't have a setter on a read-only value. Therefore, you have to either remove the set entirely, or technically you can do this, because that's not actually changing the value of height, even though there's a set. So therefore, that would be technically okay. Don't do that though. Just get rid of the set entirely. Okay? Now, if you got rid of set entirely, you should not mark this as read-only. You can't have both. It's either at the property level or it's at the getter level. Okay? So I'm going to back this out and mark the get as read-only because we do want to be able to set the height. Okay? So that is the read-only members. We can mark something as read-only, which prevents that, or it reduces the cases of a defensive copy, which takes up more memory and more processing. So therefore, it makes our application more performant. Okay? This is a small change as far as how many times we're going to use this. But I did want to show it to you and go over the various nuances of it, so it's kind of in your bag of tricks for later. All right, let's move on to the next one. Before I do, let's go ahead and paste at the very top. I'm going to paste a link. And that link will give you some more examples of read-only members and how they work if you had some questions. Okay? So next we're going to say add a class. We're going to say to-default interface methods. Now, this is one where we're going to spend a little more time and it's going to be a little bit more relevant to you. So let's make sure we go over this in detail. I'm going to wipe out this class and I'm going to create a public interface instead. I'm going to call it IShoppingCart. And let's put in here just a string calculate total. That's it. Nothing more than that. Okay? And then I'm going to create a public class down here. And we're going to say shopping cart that implements IShoppingCart. And we're going to implement that interface. And down here, what we're going to do is we're going to return, you know what? Let's make it even easier. We're going to make it void. And instead of returning, what we'll do is do a console write line. This is calculate total in the shopping cart class. So this is not actually doing any shopping cart work. This is not a real class you can use in a real application. It's just for demo purposes. But I named it this so that we can have some, kind of reference as to what this would be doing and how it would work. Okay? So now we have an interface that has one method in it that's calculate total. We have shopping cart, which is a class. It implements IShoppingCart, therefore it implements the calculate total method, which is a returns void. Okay? And there we just call a console writeline. That's all that happens. Now, what would happen if this shopping cart class is in production, we're using it, we've got the IShoppingCart that works against it, and we say, you know what? We need to calculate a subtotal as well. So if we just said void calculate subtotal, like so, that breaks this class because it's no longer implementing the interface. And you go, well, that's not good because I don't want to change this right now. So what do I do? Well, it used to be the solution was you cut it out of here and you create a public interface I better shopping cart, and then you would paste in that one, and then for any new class it could implement the I better shopping cart, which, oh by the way, inherits from IShoppingCart. And so now it has both the calculate total and the calculate subtotal. And that would work, but then there's a problem of what happens when you say you want to calculate tax, and you've already had something that implements I better shopping cart. Well, now you create a new interface, and now you have I better shopping cart, or I better shopping cart with tax. You know, it gets confusing. You have 18 different interfaces because you've got these different iterations, and you don't want to change all of these classes to use the latest interface because maybe that code still works just fine. Why change if it works just fine? So there's a new way of doing this. And that is the default implementation. Okay? So if I were to add this in right now, it's going to yell at me and say, IShoppingCart is not fully implemented in ShoppingCart. But I can say, you know what? Let's have a open and close curly brace, and here I'm going to say the default is let's copy this code right here. We're going to change it. Instead of saying this is the calculate subtotal in the IShoppingCart interface. Let's just say this is the default IShoppingCart interface or implementation. Okay, this is the default IShoppingCart implementation. Notice how IShoppingCart is no longer yelling at me because I don't have to implement this or calculate subtotal because there's a default implementation for it. So what I can do now is I can create a new public class, let's call it Better Shopping Cart, that implements IShoppingCart. And notice I only have to implement calculate total, but I can say public void calculate subtotal as well. And now let's copy this line. This is the Better Shopping Cart implementation of calculate subtotal. Let's put that at the end too. Okay, so this is the Better Shopping Cart implementation of calculate subtotal. I can override that. I can override the default with my own in this class. All right, and that's just copy this calculate total as well. And this is the Better Shopping Cart class. So you can see here, the shopping cart, we didn't have to change at all. Nothing changed in this class. It still works the same way. But in the Better Shopping Cart, we can now take advantage of the calculate subtotal and use that as well as implement for the calculate total. Okay? So how does this benefit us? Well, this is really designed for the primary design. Let's put it this way. The primary design is for when you're talking about making changes to an interface to add more things as you go. So you already have something working, but you want to add more features. So you add your methods and create a default implementation of them, and then you're good to go. Okay? So you can add to that, you can add your default implementation, and you don't affect any of your old classes. And you may say, well, what if you don't know what to put in the default implementation? Really, you don't have to, because we could have put no code here, and that would have been okay. Because remember that shopping cart doesn't call calculate subtotal. It doesn't have access to it. It doesn't know anything about it, because it was created before that was a thing. And so we don't have to have any implementation here because it won't be called. And for better shopping cart, it will probably implement its own. However, in this case, it's probably good to have something valid for your default so that if you don't do this with your new class, but you do call calculate subtotal, that it actually works. Okay? So that's one of the benefits, is that it allows us to have the default implementation, which means we don't have breaking changes for our old classes. So the first and probably one of the primary things this allows us to do is it allows us to extend an interface safely. All right? The next thing it allows us to do is it allows us to have a more specific implementation. If this calculate subtotal, if that was 95% of the case was always one thing, then just having that code here allows you to not have to call that anywhere else, or not have to rewrite that anywhere else. It's kind of like inheritance. Now, there are some limitations to that. I'm going to show you that in a minute. But it does allow you to have the generic or general implementation, and then have your more specific implementations where you think it's necessary. And finally, by having these defaults, we can also allow for some parameterization of even our general methods. So let's say that instead of this keyword default, maybe that changes. Maybe for the most part you use default, but every once in a while you want to use something different for that. Well, what we can do is we can say, let's create a public static void. Notice I said public and I said static. That's interesting. I'm in an interface, not a class, but this is allowable. Let's set default name. So this is a static void, a public static void method inside interface. What this allows us to do is set private static string or values. So private static string in our case. Let's go default name equals, and let's start with default. Okay? And I can say, well, default name equals name. So now this method can change this private static string in my interface. Why is this useful? Well, I could come up here and put a $sign for string interpolation, and instead of this keyword here, default, I can say default name, like so. Now it's going to not change anything if you just call it as is, but I can make a change in my class. So for example, let's comment this one out. Okay, so we have not overridden the calculate subtotal. Let's create a constructor, CTOR. For the better shopping cart, what I'm going to do is I'm going to change this default name to be something like default better shopping cart. Okay, so I can say set default name. Well, how do I do that? I say iShoppingCart dot set default name to default better shopping cart. Like so. So the constructor is going to call this method. And it's going to update that static string to be default better shopping cart. So this is the default better shopping cart IShoppingCart implementation of calculate subtotal. Okay? Why would you do this? Again, this part is really an edge case. It's not something you should be doing all the time. However, if you're using that default case, that default implementation, and it just needs to change a little bit, then this might be the way to do that. So for example, calculate sales tax. If everybody has a sales tax generally of 0.06, so 6%, but there's one area that has 0.07, maybe you make that a private static double sales tax value. And so you do your calculation of sales tax using that value. But in the one case where it's different, you could make that change to 0.07, and now you're able to run it with a new value. But again, that is really an edge case use. And I'm going to show you where this can fall down a little bit. So let's go over to our program.cs. We're going to call let's call both of these. So better shopping cart and shopping cart. So let's start with better shopping cart. Let's just say cart equals new better shopping cart. Now remember that I put in here, I put the console write lines right in these classes. So these are user interface classes. Normally I'd want to abstract that out probably so I can use them in other places besides the user interface, but again, this is just a demo environment. So make sure you keep track of that. This is a demo environment. All right, so let's do this. Let's say cart dot, and look at our methods. We only have one, calculate total. Why is that? Why don't I have calculate subtotal? Well, the answer is because it's not in the better shopping cart. There is no calculate subtotal. And you may say, well, yes, there is, Tim. There is the interface has a default implementation of calculate subtotal. Therefore, it's in that class. No, it's not. Okay? So the reason it's not there is because we're referencing it as the class itself. If, however, I said IShoppingCart, and I said, now I see calculate subtotal, not just calculate total. Well, why is that? Because I've said this is an IShoppingCart. Remember, an IShoppingCart, normally, let's think back before you learned about C# 8.0. Interfaces were just public methods and properties and events that were known for that interface. So if you had method A, method B, and method C, but the interface only said method A, and you use the interface value, you'd only have access to method A. Okay, remember that? Well, the same is true in reverse. If an interface has more methods than your class does, then the only way to get access to those methods is through referencing it as an interface, not as the concrete class type. Okay, so that's one of the tricky bits here. All right, so now we have calculate subtotal. Let's do this. Let's do another IShoppingCart. We'll say cart2 equals new, and this is just shopping cart. And now we're going to say cart dot calculate subtotal. All right, so I'm doing a calculate subtotal on both shopping cart and better shopping cart. Let's run these and see what happens. All right. Oops. This is interesting. I said console write line, I thought, but it seems like it didn't do a write line. It seems like it did a write instead. Not sure why that is. Well, let's do this. Let's just make sure that we have a console write line in between. That's a weird, I think it's a bug, but I'm not positive. There we go. So this is, I think it has something to do with me stretching the window. But anyways, both of them say this is the default better shopping cart, iShopping cart implementation of calculate subtotal. Now, wait a minute. The second one is a shopping cart, not a better shopping cart. So why is it that it's getting access to the better shopping cart's value here? The reason why is because it's static. And static means it lives across your entire application, not just a single instance of it. Well, that's a little bit of a problem because depending on the order of this, if I were to change this order, let's just do this. I'm going to move this to the top. And yes, I'm still running. The purple says you're still running. All right. So I don't know why it says cart instead of cart 2. If I were to copy this and paste this, so now I've moved them around. So cart 2 is first with shopping cart, and then it's cart with calculate subtotal. Let's run it again. And now we get, this is the default iShopping cart implementation, and this is the default better shopping cart implementation. Those are different. So just by changing the order in which I instantiated these two instances, I changed what the interface value was. That's a little scary. And that's why I say that let's close this out. The value here, the idea of having a static void and a static string, a private static string, all that kind of stuff, I'm not a big fan. Okay? Because that can cause some problems. Now you might say, well, what if you just took off the static and didn't make it static? Well, guess what happens? The interface cannot contain instance fields. You can't instantiate an interface. So you have to make these static. So once you make a change here, by calling this the set default name, you're changing it for your entire application. So this can change expected behavior into unexpected behavior at an unpredictable point. Because maybe we had been using shopping cart and then we decided to change it to better shopping cart. Or only under certain circumstances do we use better shopping carts. But so that's going to cause these random weird bugs. So be very, very careful of this. So I wanted to show it to you because you're going to see examples of this, and you're going to see where, hey, this is pretty cool, and you can do some really cool stuff with it. Yes, you can, but you can also do some really bad things with it. So I would avoid doing this if you can. So that was one of the 3 reasons why we would use these new values or new abilities of interfaces. One of them was to allow parameterization of things like your default methods. Okay? So I would say take that off your list and put it in the, in case of emergency, break glass type situation only. You have to be very sure you know how this is going to work, and this could very easily add weird transient bugs that only show up every once in a while. That's what transient is. And so it's very, very difficult to debug. So I would take that off a list of positives for this and put it more in the emergency uses only. Okay? But we still have those 2 positives, one of which was to easily extend an interface. So notice there's no implementation here. We can extend an interface by adding something to it without breaking the current implementations. That's gold right there. That's the real value here. Now there's the other one I mentioned, the other benefit I mentioned, which was to allow a more specific implementation. So let's calculate subtotal. We have the default value, and then we can just call that if we want, and let's get rid of this right here. Or we can do is we can override that with our value instead. So right now, back over here in our C# code again, we have, this is the default iShopping cart, and this is the better shopping cart implementation. Okay, so we've overridden that call, the calculate subtotal. That can be of benefit, but here's the downside of that. And that is you have to refer to it as the interface, not as the implementation, the concrete class. Because then this works because we actually implemented it. But if we go over here and do this, you can't call calculate subtotal. It says, I don't know what that means because you didn't implement it. So one of the questions that these default implementations raise is, well, isn't this just an abstract class? So an abstract class says, here's the properties and methods you need to have, and maybe events too, and then here are some default implementations of some of the methods. And so you can inherit from that and have that source code be your starting source code, and then you can override it if you need to. This does something very, very similar, and so the question is, aren't these two the same? And the answer is still no. And the reason why is because you have to reference the interface type in order to be able to call these default methods, unless you override them. Okay? Let me just make this hopefully a little clearer, but it might make it a little muddier. We'll see. Let's do another interface. Remember, we can have multiple interfaces that we implement. We cannot inherit from multiple classes. So you may say, this is awesome. Now I have multi-inheritance. Not really. Okay, so public interface, let's call this iSubtotal. And this is going to have one method. I'm going to say, you know what, let's give this a default implementation as well. So this is the default iSubtotal implementation of calculate subtotal. Okay? So I've got another interface with the same name method. Both of them have a default implementation. So which one wins out? Let's find out. Okay, so I have shopping cart, which does not implement this calculate subtotal. Both of these have a calculate subtotal, and both of them have a default implementation. Let's run this code again. We try to, and oh, by the way, I've got to make sure it's an interface. So which interface do I use? Well, if I use iShopping cart, that's cool. Let's run this. This is the default iShopping cart implementation. All right. But what if I instead use the iSubtotal? This is the default iSubtotal implementation. So it depends on which interface I use, which default value I get back. That's a little nerve-wracking as well, because you may be expecting one value, this one, but if you just change the variable type that it's stored, the iSubtotal instead of iShopping cart, now you get a different value for that same method. Is this going to happen all the time? Probably not, which is actually worse, not better. Because you may say, I don't think I'll ever do that. And that's what's going to make it so difficult when you do. Because when you do, then you're going to have some weird bugs. Because if you have the same method name in both interfaces, and some variables use one interface and some variables use the other interface, you will get different values for the same method. That isn't ideal. All right, so let's go back to what is the value of these default implementations. I think the biggest and probably the only value you should focus on is the extending interfaces safely. That, in my book, is a real winner. It allows us to create that one interface instead of the extended, I better shopping cart, I better shopping cart with tax calculation, I better shopping cart with tax calculation, and so on. Okay? That default implementation allows us to do that, allows us to expand our interfaces without having to create new ones. That right there is a winner. The more specific implementation, not a big fan of, because you have to use the interface type in order to get that default method. Now you can call the method as long as you implement it without using the interface. So I have the concrete type here, but because the better shopping cart overrides the calculate subtotal, I can call it. But if I make this a shopping cart instead, I can't call this because of the fact that shopping cart does not override it. It uses the default. Therefore, it has to be I shopping cart. So I'm not a big fan of that. Okay. And finally, I'm not a big fan of these public static items, whether it's the values here, like the string and other variables, or the method to set them. Yes, you can use them for parameters, but again, that changes it for your entire application. That might not be what you want. My earlier example of tax calculation, where normally it's 0.06, but sometimes it's 0.07, that would only work here if where the application was physically located was what determined what the calculation should be. So if you're in a certain state, then you get this calculation. You could set that. However, if you're trying to do calculations on some that are and some that are the default, you couldn't use this. Okay, so this is a very, very limited scope of what you can benefit from this. All right, so again, coming back to finally, extend the interface safely. That's the big win here. Now, there are other things that you might not be aware of, but this does allow for something more in line with what Android does, and there's another language as well that does it, where .NET wants to interface with these languages. So Xamarin works with Android, and so having these interfaces that can do this allows for a better interfacing with what Android is doing, and so it allows for us to have that cross-platform code and cross-device code more easily. So there is a benefit there as well. But the benefit to us as C# developers primarily is going to be the extending the interface safely. Okay, I'm going to grab a link for you, and I'm going to put that at the top here. This link has more information about the default interface methods and what you can use them for and how you use them. All right, let's move on to the next one. This one will be faster. Let's do 3-. We'll call this switch expressions. All right, we'll say switch expressions. And I'll make it public static. We're not even going to call this, but I just wanted to kind of structure it so you can get to a method and start using things. So let's see a method called doMath. All right, it's going to take in a x and a y. We're going to actually have to take in one more thing, and that's a enum, because we're going to say, you know what, this is not an add method or subtract method. This is a doMath method, and it's going to do the add, subtract, multiply, or divide depending on which value in the enum we choose. So let's create a public enum, and we'll call it math type. And we're going to have add, subtract, multiply, and divide. Again, disclaimer, this is sample code. and I'm putting the new in the same area as my class, and the class is named differently than the file name. These are all things you shouldn't do in a real application. This is just for demo purposes. Math type. So math type is going to be, let's just call it math type. There we go. So normally what you'd do in this kind of case is you'd say, okay, let's create a double output. Let's start it off at 0 just so you have something. And then we'll do a switch. And we're going to say switch on math type. And it's going to create my cases for me. That's kind of nice that it creates those for me. And at the end, we'll return output. And then inside here, we're going to say output equals x plus y. And let's copy and paste this again, only this is minus. And this one is the multiply, and this one is the divide. And no, we're not doing error checking here for divide by 0. But then down here, we can say, instead of break, we're going to say throw new exception, bad info passed in. Okay? Because if we can't do one of these 4 types, somehow you broke the enum. Okay? And so we're going to throw an exception. Shouldn't happen, but that's what it's going to be. All right. So now we have this switch with all these case statements and breaks and all the rest. We can do better now when we talk about the switch expression instead of a switch. Okay, they're a little different. What I'm going to comment this one. You know what? I'm not even going to comment it out. I'm going to do it right above, and then you could comment it out if you actually want to use it. We're going to say output equals math type, and that's the variable right here. Math type switch. And you may say, wait, that's a little weird. You put switch after math type. Okay? It's normally switch and then in parens, math type. That's because this is a switch expression. And they wanted to make sure that you knew that it was different. It was not a switch statement. Therefore, they put it afterwards so it's not confusing. Okay? We need to put a semicolon at the end of this. Now, right now, it's saying, hey, this represents a double precision floating point number. It's going to return a double. How does it know that? Well, because we're assigning it into a double. All right, so let's do math type dot add. Oops, capital M. I probably should have named it the same math type and math type. You know what? Let's do this. Let's do it originally asked us for. That's a little more clear. So it's math, not math type. Okay? So math is the variable, math type is the enum. All right. So math type dot add an arrow function x plus y. Put a comma and say math type dot subtract arrow function x minus y, comma, math type dot multiply the arrow function. You catching on here? X times y, comma, math type dot divide is left, and the arrow function x divided by y, comma, and then this last one, underscore, which is the discard character. Otherwise, we're using this in place of a default. So this is default. So for anything else, we're going to say throw new exception, and whatever that message was, we'll copy and paste that message. Bad info passed in. Okay? Oops, no semicolon. That's it. Okay? So this right here is the equivalent of this right here. This right here is a lot more compact. Okay? And so if you're doing a quick assignment to a variable based upon a switch, instead of writing these case statements and then the breaks and then possibly curly braces as well, you can just do this. All right? And you just have a little expression, and this is going to return into output. All right? So this value is going to come over here into output. All right? So that is a switch expression. Also, one minor thing to note is this discard character, the underscore. You're going to see that in other areas as well where you have pattern matching, where if nothing matches the pattern given so far, you can just say essentially everything else. Okay, that's the discard character. Don't care about it, is essentially what it is. Whatever else it is, then do it. Okay, so that is the difference here. Also note that there is no fall through. So you can't say math, add, and subtract, do something. It's math, add, and math, subtract. So here for the add, I could do this. You can't do that up here. All right? So that is something to note. If you need a full power of a switch statement, then you have to do the full switch statement. But if you want this switch expression, so this is switch statement. Let's put in parens. And this is a switch expression. All right. So again, when it comes to how much you're going to use this, you're not going to use it a ton. But there will be cases, and more cases than some of the other things we've looked at today, there will be cases where it just makes sense to create a switch expression and cut down some of those lines of code and make it a little bit more compact and a little bit easier to read. And this is how you would do that. All right. Let's move on to the next one. This is a fun one, and this is one you will use probably quite a bit. This is let's do -- using declarations. And we're going to change this to using declarations demo. And make it public static class. And I'm going to call this, so I'm going to create a public static void convert files like so. Now, when you convert a file, what we're going to do is I've got a file here. Let's pull it up. So I've got this test file here. And this test file has test line 1, 2, 3, and final test line. Okay? That's our test file to work with. And there's no other text files in this folder. All right. So what I'm going to do is I'm going to open up a stream to read that file line by line. And then I'm going to open up another stream to write to a new file based upon the lines I'm pulling out of the original file. All right? Yes, this is a contrived example. Yes, I could do this easier in other ways, but I want to show off a couple of different things you would do with using statements. Now, it is a little bit confusing, but these up here are also using statements. That's not what we're talking about. This is the shortcut. So instead of saying system.text.something, you can just say that something because you've got a using statement up here. Well, in fact, we're going to add a new one. So using system.io. We're going to use that in just a minute. So the using statement I'm talking about is where you'd say using, and then parens, var input file equals new stream reader. And that stream reader, we're going to have the @ symbol. And what that allows us to do is say d:/demos/test file.txt. That's the name of that test file. So you're going to read this file. What this using statement does is it says, since the stream reader implements the iDisposable interface, I know there's a dispose method on that. And so at the end of this curly brace right here, I'm going to call the dispose method on stream reader so that we don't retain that stream or keep it open longer than we need to. That's a memory issue, right? So we want to make sure we close that out and close it out properly so you don't have any kind of hanging connections out there. All right? So this is a pretty common thing to do for anything that uses resources outside of our application. So database connections or opening images or files, those types of things, you'd almost always have a using statement for. Well, the next thing we need to do is we need to open the ability to write to a file. So now we have another using statement. So we have to say using, and then in here we're going to say var output file equals new stream writer. And again, we're going to say at, in our quotes, double quotes, d:/demos/ let's call this output file.txt. So now we have a nested using statement. Okay, we're going to close this one out when we get to here, and then we'll close the next one out when we get to there. All right. So now we can say while, and let's just say, let's declare it up here, string line. And we're going to say while, and we'll put in parens, line equals input file dot read line. Okay, I put the whole thing in parens. So there's 2 parens at the start, there's 3 closing parens at the end, and the reason for that is I'm going to say not equal to null. So read line is going to put the string of that line into line. However, it might put a question mark if it doesn't find anything. All right, so it's going to return a null value. So while it's not null, I want to write to the output file. So output file dot write line. Okay, and then let's put a counter in here just so we have a counter. In fact, let's return that counter value. So int. So I need to put that all the way outside the using statement here. So int output equals 0. And then every time we add a line, I'll add 1. All right. And then at the very end, after the using statement, I'm going to say return output. All right. So this is the traditional way we're used to using statements. And this will work. However, there is an easier way. Let's comment this code out and let's look at using declarations. So I want to create this declaration right here for the input file. So I would say using and then paste that in and put a semicolon at the end. Notice there's no curly braces. I said using in front of the variable type, which is var in this case, okay, which is stream reader. But just doing using in front of it creates a using statement, just like this one did. The difference is there's no curly braces for scope. So how does this work? Well, at the end of the scope, once this variable goes out of scope, as it's no longer needed, it will call the dispose method on the stream reader. So it's still that safety of a using statement, but it's no longer necessary to nest these things. So when I have 2 of them, and that's why I did 2, I can say using and have the output file as well. Now, I have a lot less nesting going on. I can copy and paste this code. And let's uncomment this. Now this is the same code as this is. It's just there's a whole lot less nesting going on. There's a lot less curly braces to deal with because our using statements will get terminated and have the dispose method properly called when this variable has gone out of scope. I believe it was last week I used this in the solution for the weekly challenge. Because they had a couple of using statements, and I said, you know what? Let's get rid of these curly braces and make it a little more readable by using the using statements, the using declarations right in line instead of having these curly braces here. Okay? So that is using declarations. let's look at number 5. So we're going to add a class, 5-indices and ranges. This is a fun one. I like this one a lot. Public static class, and we'll say indices and ranges demo. And then in here we'll have a public static void demo method. Let's create an array. And the reason why I have an array is because an array is an easy way to get something with an index on it. So indices or index, okay? That's what an indices is. So var places equals new string array. And we'll put some initial values in here. This is just for demo purposes. I'll say first, and then second, and then third, fourth, and fifth. Okay? So if you were to look at this and you were to say, let's put a comment here. If you were to say places and then say 0, that's going to equal first, right? And if you were to say places and say, it's 0, 1, 2, 3, and 4. So places 4 is going to equal fifth. Okay? That's how the indexing normally works, and it still works that way. However, there are new ways to work with indexing that make life a little easier. For example, what if you wanted fifth, but you didn't know that there was 5 items in here? How would you do that? What we'd do is we'd probably find the length and then subtract 1. So we do something like this, where we'd say places, and then in here we'd say places dot length minus 1. This is pseudocode. Something like that. Okay? But that's ugly. All right? What if there's an easier way? And there is. So I'm going to do a console write line here, and I'm going to do a string interpolation and say the last item in the list is, let's do our curly braces here, and we'll close them out as well, and say places, but what I'm going to put inside the square braces, it's not 4, and it's not places.length minus 1. It's going to be the caret and then 1. It's going to be the first item at the end, or position 1 from the end. So this is the from the end item. Okay, so this character right here says, I want you to give me the first item from the end, which is fifth. Now, it may be a little confusing. This is one of those things that sometimes gets people tripped up, is from the beginning, it'd be 0 with the first item. So why isn't it 0 from the end? Why isn't it like this? And the reason why is because this position, the position right here, is actually after the end. It's at the end. Okay? So at the beginning, we're at the beginning, and then we see this. At the end, we're already at the end. So if you ask for the end, that's what this is right here. It's after the fifth. So therefore, we have to say 1 back. That's the last item in the list. Now, what if you want the second to last item? Let's copy and paste this entire thing. The second to last item is 2, like so. Kind of cool, huh? Let's put a console write line empty line here. I'm going to do all this so you have it documented. We will run it probably, but I wanted to show you in a way that you can take it back and look at it with different examples. In fact, what I'm going to do, I have pre-built some scenarios. I'm going to paste these in now. Then we're actually going to do the scenarios. So I'm not pasting any code that you would be learning about. Okay, so I just pasted in some code with some examples. So this next example is place 2 and 3. All right, so we're going to say only give me items in the second and third spot. All right, so that would be position 2, or the third item, and the fourth item. So these two items right here is what we're going to try and grab. Let's do that. So we're going to do a for each. So item in places, and then I put my square braces, I'm going to say 2.4. And what that does is it says start at position 2, which remember, that's zero-based counting. So 0, 1, 2. So start at 2 and go up until 4. So 2, 3, but I said up until 4, meaning don't include the fourth item. So don't include this right here. So this is going to be 2 and 3. And now we'll just do a console right line of item. All right. So that's allows you to put a range in. And so whatever range you want. Just make sure your array can handle it, because now your array has to have 3 items. It actually has to have 5 items because of the fact that you said end before the fourth place, which is 0, 1, 2, and 3. So, and before the fourth. So that's kind of hard-coded. Well, we can do it better. We can say, you know what? Let's do another for each. And this time, we're going to say in places, and let's do from place 1 to 1 from the end. Okay? So we're going to start at position 1, which is this second item. So second item. And we're going to stop before we get to the last item in the list, that caret 1. So therefore, we're going to start second, we're going to have third, we're going to have fourth, and we're going to stop before we get to fifth. Okay? And actually, I have one too many numbers here in my comments. Let's make sure we change that. So she places 1, 2, and 3. Okay? 1, 2, and 3, but not the fourth. All right, let's do one more. And this one is going to be everything up until or before that last one. And again, I have one too many numbers. I'm not sure why I had that there. All right, so let's do this again for each. And we're going to say places, now has square brackets, but this time I'm not going to give it a starting number. I'm just going to say dot dot and then my caret and then 1. All right, and so what that does is says, you know what, start at the beginning and go until just before the last one, which means we're going to say start it here, this one, this one, this one, and this one, but not this one. All right, and this last one here, we're going to say for each var item in places, and it's basically the opposite. We're going to say 1 dot dot. And what this will do is it will, again, I have one too many. This is what happens when you manually calculate indexes. It will start at position 1, which remember, zero-based counting. So what this will do is it will start at the second item. So it's going to start here and go all the way through the end. Because it says, I don't care about the ending. Okay, go through the end of it. You don't have to identify what the end is. All right, let's run this just to see to make sure they actually work the way I expect them to. Let's go over to program. We're going to comment these out. And we're going to say Indices and Ranges .demo. And let's run this. All right. So the last item on the list is 5th. That makes sense. The second to last item on the list is 4th. So this one is Whoops, looks like I didn't put my for each here. Let's go to the next one. So 1 to everything but the end. So second, third, and fourth. Okay. So this should be everything up until the end, right before the end. So first, second, third, and fourth. And then this one should be from position 1 till the end. So positions 1 through 4. So second, third, fourth, and fifth. Those are all working correctly. Let's fix this first one right here. Let's go back to our indices and ranges and look and see why we're not printing this out. Oh, we should have. Let's run it again. We did. Now I don't know. You know what? I bet if I stretched it out, there's that weird issue again. When I stretched it out, I actually put third on the previous line. So third and fourth. That's odd. Let's run it again. This time I won't stretch it out. There we go. Third and fourth. Okay? Because we started at position 2, which is the third item in the list. And we said, but end at position 4. Don't include that. So therefore, it's position 2 and 3, which is third and fourth. All right? And that's it. So that's how you do the indexing, where you start at the end and work backwards, or where you do ranges like so, and where you can even mix and match those two, where you're starting at the beginning, but then going 1 from the end, or 2 from the end, or 3 from the end. You can even say, give me the fourth from the end, or the second from the end through the end, or something like that. There's a lot of different ways you can mix and match it. You can also not specify the beginning of that range or not specify the end of that range. And so at the beginning, it assumes that you mean start at position 0. And the end, it assumes you mean go through the last item in the list. All right, so that is indices and ranges. Let's add one more. So it's the last thing we'll look at today. And this is going to be number 6, and it is null coalescing assignment. All right, let's call this the null coalescing assignment demo, and we'll make it public static class, and make a public static void demo to call. And the other thing I'm going to do for setup here is I'm going to create another class, public class list demo. Okay, this is just a demo here. And I'm going to say prop, and this is a list of type int, and it's going to be my lucky numbers. Not that I believe in that, but it's my lucky numbers. Okay. Now, what have you noticed about what I've done so far? Maybe you haven't, but I didn't instantiate this list. Okay, so if I were to use this up here in demo, I would say var demo equals new list demo. Let's call it var example. Okay, probably better because I have demo all over. So var example equals new list demo. I'm going to say example dot lucky numbers dot add 15. Because why not? That allows it. I'm going to do a for each here. I'm going to say for each item in example.luckynumbers. I'm going to say console write line. I have my string interpolation. And here I'll say lucky number is item. So I'll loop through and print out all my lucky numbers. All right. So I've created this little demo method that all it does is it instantiates this class. And then in that class is one property which isn't instantiated, but we'll get to that. And I say, okay, I'm going to add a 15 to that lucky number list, and then I'm going to loop through that list and print out all my lucky numbers. So let's grab this here. Now I'm going to call this in, let's close out some of these other ones. I'm going to call it in program.cs. So I'm going to say null coalescing assignment demo.demo. All right, and this should print out my lucky numbers. When I run this, I get this. Unhandled exception. Null reference exception, object reference not set to an instance of an object. How many times have you done that? I've done it quite a bit. Okay? The longer you work in software development, the more you'll do it. So you go, oh, I know the problem. So you can say, well, I'm going to fix that up here. I don't have access to that class, or maybe I'm not supposed to change it or whatever. I can say, no problem, example.luckyNumbers equals new list of int. And now if I run this, I get lucky number is 15. Cool, it all works. Okay, that's all code we would have written normally. All right, but what if the developer of the list demo class, who is not me, comes along later and says, oh, you know what? I never instantiated this. And in fact, there's some default lucky numbers out there. So let's create a constructor where I say lucky numbers equals new list of int. And by the way, let's put the number 21 in there because I think that's always lucky. Cool. Nothing changed in my code here. It's just that I changed this class here, or somebody else changed this class. Now I run my code, and I get 15. Well, wait a minute. What happened to my 21? Well, you wiped it out when you did this. You say, oh, okay. Well, I need to take that out, and if you do, then your code will work. 21 and 15. Cool again. Except for the fact that we have to change our code because their code changed, and that's not ideal. And they can say, well, I've got a fix for that. So what we're going to do is we're going to cut this code out here. I'm going to say if example.luckyNumbers equals null. Then do that. So now, if I run this, I get 2115. And if this was not here, and I run this, I still get 15. Because even though I didn't instantiate it down here, it found that out here and instantiated it. Cool. Except for the fact that that's a little bit of extra code. Couldn't we do it a better way? The answer is, why, yes, we could. With C# 8.0, what we can do, let's comment this code out. What we can do is say demo.luckyNumbers, example. I called it demo before. Example.luckyNumbers double question mark equals new list of int. And what is this double question mark equals? Well, this is the null coalescing assignment. And so what this does is it says, let's evaluate example.luckyNumbers. If it is null, then I want you to do this. Assign this value into it. However, if it is not null, I don't want you to even evaluate the other side of this. Just leave it alone. All right? So now, with this one line of code, we replace these lines of code. If we run this, it says 21 and 15. If I were to comment this out, so it's no longer being instantiated, and when I run it again, it still says 15. So by using this one line of code here, so instead of just, this is what we originally had that broke things, I just add double equals in that spot, and it solves the problem. Okay? So now that's the equivalent of this right here. It's safe to use, and it allows us to not step on someone's toes if they decide even later to instantiate that and even pass in some values into it. This can be a pretty valuable piece of code in certain circumstances. It's not a huge use case, but there are quite a few circumstances that might you might need this for. Okay, we already have the null checks. So if I were to say example question mark lucky numbers question mark dot lucky numbers question mark dot add 16 like that we already have. And what this does is it says, hey, this question mark here says if this is not null, let's look at this property. And if this property is not null, then let's do this. All right, that's the not null side. This down here is the, hey, if it is null, what do you want to do side of things. Okay, so it's saying if it is null, then do this. But if it's not null, don't do anything. So there's both sides of the coin here with this, the null check with a question mark. Okay, so question marks typically are saying, let's do a null check. Okay, so that right there is the null coalescing assignment. If you want to learn more about that and what you can use it for, there is a reference for you. Now that's not all of the things that C#8 added. There's some other things that are small and some things that are bigger, but only in limited use cases, like async streams. If that's something that you need, they're there. One of the small ones is, it used to be if you had to use both the @ symbol and the string interpolation symbol, the $, you had to put it in this order, the $sign first. Now you can move this around and put the @ symbol first, and it's just fine. Okay, that's one of the little things. But there's some other things you might want to look at, but these are the ones I thought that might impact you, most of you, in more circumstances. Okay. Even some of these are pretty targeted, but I figured that this might be tools to put in your toolbox. Okay, if you want to learn more about what C#8 is adding or has added, you can go here to this link. Okay, so I put links in here to the various parts if you want to learn more information. And this one is if you want to go into an overview of what else is in C#8 that might apply to you or might apply to your circumstances. You can go there. Okay. So that's kind of a big high-level overview. Hopefully we've covered why to use things or why not to. And that's the bigger one here, is there's a lot of things in here, especially with the interfaces. There's some things in here where they look really cool and you get some ideas about, hey, I could do this, like multi-inheritance. It's not really that way. And so I hope that you got the idea of when to use these things and when not to. Thanks for watching. Thanks for sticking around to the end. Don't forget the source code link is down below. Also the links for Patreon and for my mailing list. Next week comes out the upgrade to .NET Core for the IAmTimCorey Retail Manager series. So don't forget to check that out. That's going to be a big deal. We'll probably have multiple videos, and we'll definitely have some bonus material for you Patreon people and also for you mailing list members. All right, so make sure you're on those lists. Thanks for watching, and as always, I am Tim Corey.